this is a question based on number system remainders which came in CAT 2024. So my advice to all of you is pause the video, try this question on your own and then look at the solution. So let's discuss this one. The question is 10 raised to power 68 when divided by 30, what is the remainder? Now this question can be solved in multiple ways. The first one is we can use the binomial expansion method here. So what is binomial expansion? When a plus b raised to power n is expanded, in the expansion of this there will be n plus 1 terms, and the first n terms are multiple of first n terms are multiple of a. So if a term is a multiple of a and you divide it by a, it will leave remainder 0. It will be complete multiple. The last term of the expansion is b raised to power n. Now we will use this binomial expansion for this question. 10 raised to power 68 when divided by 30. So we can write 10 as 13 minus 3 whole raised to power 68 divided by 30. Now we have a minus b whole raised to power 68. In this case, it will have 69 terms, out of which first 68 terms are multiple of 13, and when divided by 13 will leave remainder 0. And the last term of this expansion will be minus 3 raised to power 68. Please keep the sign in mind. If it is a plus b whole raised to power n, the last term is b raised to power n. If it is a minus b whole raised to power n, the last term is minus b raised to power n. Though in this case, minus 3 raised to power even is a positive number. So which means I can write this as 3 raised to power 68 divided by 30. Now I need to find some power of 3 which when divided by 13 will leave either remainder 1 or minus 1. So 3 cube is 27. 27 when divided by 13 leaves the remainder 1. So can we write this number in form of 3 cube something? 68 is not a multiple of 3. So let me write this as 3 raised to power 3 into 22 plus 2 divided by 30, which further can be written as 3 cube whole raised to power 22 into 3 square divided by 30. Now this is 27 raised to power 22 into 3 square is 9 by 30. 27 can be written as 26 plus 1 raised to power 22 divided by 30. Now in the expansion of 26 plus 1 raised to power 22, we will have 23 terms, of which the first 22 terms are multiple of 26 and hence multiple of 13 and will leave remainder 0. But the last term of this part will be 1 raised to power 22. 1 raised to power 22 is 1, and when divided by 30, this part will leave remainder 1. Whereas 9 when divided by 13 will leave remainder 9. And remainders are additive, multiplicative and subtractive in nature. So we can directly multiply the remainders. 1 into 9 divided by 30, the remainder will be 9. This is one of the ways of solving this question. Let's discuss another approach to solve the same question. Now, we can also use the Fermat theorem and the combination of binomial expansion. How? The Fermat theorem says m raised to the power p minus 1 when divided by p leaves the remainder 1. But the conditions are m and p are co-prime. These two would be co-prime numbers and p is a prime number. Now if you look at the given question, that is 10 raised to power 68 divided by 30. So 10 and 13 are co-prime. The first condition is complete. And the second is p is a prime number. Denominator here is a prime number. Which means as per the Fermat theorem, it says 10 raised to power 13 minus 1, which is 12, divided by 13 will leave remainder 1. So can we convert this 10 raised to power 68 in some multiple of 12? Yes. 10 raised to power 12 into 5 plus 8 divide by 30, which I can write as 10 raised to power 12 whole raised to power 5 into 10 raised to power 8 divide by 30. Now, as I told you, 10 raised to power 12 when divided by 13 will leave remainder 1, and 1 raised to power anything will leave remainder 1. So, this number will give you remainder 1. This will give you remainder 1. Now, we need to find the remainder from 10 raised to power 8 when divided by 30. Please understand, in this case, it is also not easy, but yes, now you can also use the binomial expansion here. So, you can write 10 raised to power 8 as 13 minus 3 raised to power 8 divide by 30. When you expand it, you will see there are 9 terms in the expansion of it, and the first 8 are multiple. The last term will be minus 3 raised to power 8. Minus 3 raised to power 8 is 3 raised to power 8 because it will be a positive number. So, 3 raised to power 8, and we also know that 3 cube is 27. So, what we can do, we can write this number as 3 cube into 3 cube into 3 square divide by 30. This number when divided by 30 will leave remainder 1. 3 cube is 27, divide by 30 leaves remainder 1. This part will also leave remainder 1, and 3 square when divided by 30 will leave remainder 9. So, the remainder will be 1 into 9 divide by 30, remainder is 9. So, this is another approach to solve this question. We can also solve, because remainders are cyclic in nature, so we can also use the cyclicity of the remainders. How? Let's check. We know that 10 cube is 1000, which can be written as 1001 minus 1. Why 1001 minus 1? Why we are not writing 10 square is equal to 100, and which is 101 minus 1? Because 1001 is a multiple of 30. So, it is basically 7 into 11 into 30. So, if a number is 1001 or a multiple of 1001, it will be a multiple of 13, and hence when divided by 13 will leave remainder 0. So, can we convert this number in form of 10 cube? So, yes, I can write 68 as 3 into 22 plus 2 divide by 30, which means this becomes 10 cube whole raised to power 22 into 10 square divide by 30. This is 1000 raised to power 22 divide by 30, or let me write 10 square also here, this. Now, this 1000 can be written as 1001 minus 1 raised to power 22, and 10 square is 100 divide by 30. Again, 1001 minus 1 raised to power 22 will have 23 terms in the expansion, and the first 22 terms will be multiple of 1001, and hence when divided by 13 will leave remainder 0. The last term of this expansion will be minus 1 raised to power 22, which is plus 1. When divided by 30, this part will give you remainder 1. And 100 divided by 30, 13 7 is 91. So, it gives you remainder 9. So, the remainders that we are getting is 1 and 9. When divided by 30, it gives us the final remainder as 9. So, the answer to this question is 9. Now, we have a replica question. Try that question on your own and answer in the comment box.